Can you see my screen? It's taking a little time.
Did you get to see where these recordings get saved?
I'll figure out. Okay. So we have, you start telling me the, this is weight and this is food type, right? Can you start telling me the weight observations? Maybe I should do it the other way around. Food type 1, 1, 1, 1. Two plus 1. What is the weight?
8, 12, 19, 8, 6, 11.
8, 12, 19.
19.
Tell me in
8,
sets of 3. Tell me in sets of 3.
8, 6, 11.
Next.
4, 5, 4. 6, 9, 7. 11, 8, 7. 13, 7, 9.
2, 7, 9. Right?
No, 13, 7, 9.
1, 3.
Instead of 2, it's 30. Yeah.
We're good?
Yeah.
Okay. So first of all, I'm calculating the grand mean. Okay. Then I have the mean for food 1. Same way food 2. And same way for food 3. This is what I'm doing in the first go. So all I will do is, first of all, take the average of all the items here. Okay, which is 8.6 almost. Okay. Now, difference from mean, I will do here. Difference from the grand mean, grand mean. So I will do this minus this across the board. Difference from grand mean squared. Okay. So all I will do is this value raised to the exponent of 2. Right. Okay. Fine. And I take the sum of it. So I have the total sum of squares here. This is what we will call total SS. Okay, or grand SS, whatever you want to call it. Okay. Now for food 1, I will use this formula called is equal to sum if. Sum if. Change criteria is equal to 1, comma. Some range will be so okay. The total I've gotten I will take I'll divide this by 6. So this is what I will get. And I have to lock a few values here. Now, same way, I'll create 2 more columns here, and I'll name it difference from group mean, not grand mean anymore. GROUP. Also, now for this, I will take this value minus this. Okay.
Mm.
Okay. For this one, I will take this value and minus the groups mean again of food 2. Give me 1 second. If you have any visibility issue, let me know. I can zoom in further. Okay.
Okay.
Fine. So we are done with this. 6. Yeah. And for this one, I will be taking 30. Okay. And same formula should work here. What I want is this, and I will again use the same formula here. Okay, this is not valid. Mm. 19. What the hell is happening? There's some formula I need to fix. I'll just do that. Now this
Mm.
will be my within sum of squares. That within the groups, this is the differences that are occurring for each observation of that group vis-a-vis the expect vis-a-vis the mean that it has. So for example,
Mm.
these 6 items or these 6 observations or these 6 samples are coming from food 1 category. And for food 1, we have found that the mean is 10 point whatever 66. Okay. So
Mm.
here we have used the formula and we have found the difference from that. Oh,
Mm.
I now got where I went with the wrong thing. It should be locked, should have been locked. I mean, I was surprised that how the hell is this happening? That my within sum of square is greater than my total sum of square.
Mm.
I got worried, but what will Miss T think of me? What a moron. What a moron my dad has been paying for. It should be, oh, still it is 22, 23, and this should be 24. Yeah, now I fixed it. Okay, so let's create the ANOVA table. I'm just beautifying it a little bit so that probably you will like it more.
Mm.
All borders. Okay. So now, first of all, we will have between groups. Oh, why am I not able to write groups here? Here you between group. within group. Okay, and then we have total. Total. Then we have sum of squares. Squares. I have the degree of freedom, DF. Then I have mean, SS. Then I will have F, and I will have my significance. Okay.
Yeah.
Okay. Now let's start punching in the numbers. I will have, this will come here. This value, the total will come here. Okay. Again, I will have to do this a little bit fine. And this will come here. So within. Cool. Okay. Now what we will have to is just simply to find out this, I can use this formula. Correct?
Yeah.
That is the difference. Now, this is where it gets interesting. And this is where you are doing the exact same variance calculation, but in a different light and in a different style. So how many groups do we have in here? We have 3 groups, right? So we often say groups as, we represent it by K. So my degree of freedom from between group will be K minus 1. So for 3 groups, what will the degree of freedom will be? What should be the degree of freedom for between groups? 3 minus 1? What happened to you? Are you in shock already? Hello? Hello? Can you hear me? Hello? Can you hear me?
Yeah.
Oh,
Now
okay.
I can.
I thought you're in shock already.
No.
I got worried. Yeah. So yeah, what will be my degree of freedom for between groups?
2.
Obviously. What took you so long? What took you so long to decide? Now, and we have 18 observations, right? So we know that we know it for a fact that my degree of freedom for all the observation will again be n minus 1, correct? So how much should we punch in here?
Where?
In the total degree of freedom. What happened?
For the DF?
Yeah, total degree of freedom should be how much? Hello? Hello?
Can you hear me?
Yeah, now I can. How I can.
Wouldn't it be 3?
Sorry?
Wouldn't it be 3?
Can't hear you. Sorry?
Wouldn't it be 3?
I didn't understand.
Wouldn't it be 3?
No, this degree of freedom will be 3 minus 1. So 2.
2,
And
yeah.
total degree of freedom will be how much? How many observations do we have? How many observations do we have?
Wouldn't it be 3?
Sorry?
Wouldn't it be 3?
Those are 3 groups. What is the number of observation we have?
Oh, 18.
Yeah. So my total degree of freedom should be how much?
Mm,
Or forget this. Forget this question. If I give you this information, right? Total sum of square. You know,
mm,
this is the thing that you are getting introduced to new. So forget about it for a minute. I'm discounting this. If I give you this information, right? With this information,
mm.
how are you going to find out the variance? You need this information for
Um,
finding out variance, right?
you need what?
You need this information to find out the variance.
Yeah.
Yeah. So how will you do that?
Mean minus grand mean.
No, no, no. Forget about this red part. And forget about this food as well. If this is the only information I have, okay, this is the weight. And I ask you that what is the variance of the weight that we have in this observation? How will you do that?
Yeah, so
You'll
8
first,
minus the grand mean.
correct. No, no. 8 minus the grand mean, that's correct. And then you will have to have the squares. And then you have to have the total of sum of squares, right? Now,
Okay.
what is the next step that you will take to find out the variance?
Um, after you find the sum of squares.
Sorry, what?
No, I'm saying after you find the sum of squares.
I gave you that.
Mm, divided. I want to say it's 1, but
Sorry, what is wrong with you? You forgot variance also?
no.
This is what happens.
Divided by n minus 1.
Yeah, so tell me that, na? That's
But
what
I
I'm
just
asking.
said that. You said no.
So what is the total number? Tell me the number.
18 minus 1, 17.
That's what. So this should be 17. Cool.
Mm.
Now this should be 17 minus this, the between group, right? So we have 15 degree of freedom within groups, and we have 2 degree of freedom between groups, and the total degree of freedom that we have is 17. Now, what to find out the mean sum of square, I will take the sum of squares and divide it by the degree of freedom to find that information. Then I take this information again. I do the, I divide it and find it the mean sum of square for both between groups and within group. Now, between group is also called to be the effect. And this is also called to be the noise.
Mm.
Okay. Now, an F ratio is nothing but this between group sum of square divided by the within group sum of square. So this is your F
This is
ratio.
so complicated.
It's not at all complicated. The complication lies because you don't practice. You take time to find out variance. So good luck to you, lady. Now, once we have this F ratio, we now need to go to the F table and find out that for 2 degree of freedom as a numerator and 15 degree of freedom as the denominator, what is the significance level at points? What is the value that we find at significance level of 0.05, which is said in the question, right?
Mm.
Okay. So let me see if I have the F table downloaded. Otherwise, I can always find it out. Downloads. Yeah, lucky we. Now, okay. This one is not so nice because it's will complicate little more. It's a little complicated to see on the screen. Let me try this one. Is this visible?
Mm-hmm.
Okay. So on the rows on the top, you have the numerator values. And on the columns, you have the denominator values. So we are going to check this in the at the intersection of 2 and 15.
Mm.
So what do we get?
3.68.
3.68. Correct? So that is our critical value.
Okay.
Okay. So yeah, 3.68. Now, if this my F ratio would have been greater than this, right? I could have called it to be statistically significant. But right now, my significance level for this table here, my I mean the significance is definitely greater than 0.05, which means
Mm.
that there is no real difference between the groups or the food items that are provided to the rats. I mean, the changes happening in weight is not statistically significant in this case.
This only one is greater than 0.05, right? Or 0.
This will be greater than 0.05 because at 0.05, the critical value should have been 3.68.
Okay.
Right. Right.
Okay.
If let's say if this was 4 or 5 or whatever, then we could have said that this is definitely greater than that, greater than my critical value. So my test or this group differences are statistically significant. But right now we can't conclude that. So essentially, now this is the descriptive part of the exercise. Now we come to the inferential side. In fact, I already introduced the inferential side of it by the moment I touched significance and the F table, we have already started with that. So here I am going to write the hypothesis that we will have. So my null hypothesis will be that food one, I mean, when I say food one, I mean the mean weight of food one, the mean of food one, mean of food two is equal to mean of food three. Okay. And my alternative will be food one is not equal to food two, and this is not equal to food three. Cool. That is my one-way ANOVA hypothesis. So right now, in this particular question, we cannot reject the null hypothesis. And we can conclude that the mean differences are not are the same across the group, or whatever is the question. So got it? Bored already? Tired?
Did you just do all that calculation to tell me that the means weren't equal and you cannot reject the null hypothesis?
Yes. Did I do my job well or no? I mean, I know you're bored to death already, but you can
I'm
thank me.
just so happy that I don't have to calculate this, actually calculate this.
Are you happy about it or no?
I'm so happy about it.
That you want to calculate or you don't want to?
That I don't have to calculate it.
Good luck with you, lady.
Oh.
We all have different pleasures, so it's okay.
Okay.
Yeah. I will do this. If you want, I can send it to you for reference. And I don't know if you I don't know if you can read out or maybe, you know, you can understand the formulas, etc. properly. So
Oh, I got it.
mean, mean squared. Yeah, total within.
Mm,
Cool. So I'll stop. Can you show me the question one more time? Or maybe mail it to me, please.
okay. Wait.
Oh, I have to make you this thing, huh? Host.
No,
This is what-
no, you don't have to.
Mm,
Here.
wait a second.
There, I sent it to you.
ANOVA. Imagine what pleasure Sir Ronald Fisher would have gotten if he would have. But yeah, anyway. So this was, I mean, this ANOVA test was devised by, I think we should call him Sir Ronald Fisher,
Mm,
the guy who invented that. And this is only the question, right?
mm,
It doesn't have a solution.
it does.
So are we right in our calculation or no? That's also a concern that we should share.
1 second. Yeah.
Hmm?
The null hypothesis stands rejected.
Stands rejected. Show me the solution, please. Okay, then I think I have made one mistake. Can you share the screen or no?
Oh my God, it's in Arabic.
Oh, fine. Translate it,
Wait.
please. Send it to me. I'll translate. Or it's okay. Fine. I can read it. I cannot read Arabic. I can read mathematics.
Mm,
Numbers don't have the language barrier.
Screenshot. There.
Hmm.
Mm.
Uh, SSEs. F is greater than 42 and mean sum of error. Okay. Error effect.
No, it's because they didn't like
No, but
they
this
didn't use
Hmm.
they didn't use the decimal places. We use the decimal places. That
Yeah,
changes.
exactly. Yeah, exactly.
Yeah.
Exactly. That's why. So this is, I mean, this is not an appropriate solution,
Yeah.
right?
Mm.
And decimals play all the role when it comes to uh, actual calculation.
Mm.
So, and anyway, I mean, I mean, the solution that we have made is, I mean, the critical value is very close to, I mean, the F ratio is very close to the critical value. It's only decimal,
Mm.
right? So, yeah.
Mm.
So that's what,
My laptop is overheating, so can you hear the fan?
I can, but is there anything else you want with this meeting?
Mm.
This is way too much already. I mean, it's going to end in 10 minutes anyway, but
Mm.
I can see you might, I mean, if you had a gun, you could have either shot yourself or shoot me. Or maybe you would have shot me first before you.
Oh, David.
Oh, David, David is going to get you all the kisses and hugs that you have. He's the guy. He's the man, the myth, the legend. I
Mm,
know you are going to Halifax only to meet. I mean, you took admission in Halifax because David was teaching there. David teaches there, and with this glorious book. I'll tell you. See, if you have to do the reading, just read the David's book and try reading the book that I have given you, and see the difference.
mm,
See it for yourself. But yeah, the sum total of things is basically around this. Next time around, you do the reading part. Any question you
mm.
have, feel free to ask. Okay. Or wait, just let me do one thing. Yeah, we have this now. Who needs information? Why the hell am I? Okay. So this is what we call as SPSS, new data. Okay. Okay. Let me see.
Nous avons traversé tellement d'épreuves cette année.
What happened? Hello?
Mm-mm.
Hello? Oh, my